study guide looks at classifying matter. Another option is to classify matter based on its intensive and extensive properties. An intensive property is one that does not depend on quantity. People mix these up all the time, so here's how I remember it. I remember an intensive property is independent of quantity. So I remember it's intensive and it's independent of quantity. Meaning it doesn't matter how much you have, it doesn't matter what your sample size is, you'll still make the same observation. Good examples might be things like color, odor, phase, etc. There's tons of examples. It could be things like melting and boiling point. Melting, boiling point. It could be things like, again, solubility, etc. Lots of examples. Things that I would make the exact same observation no matter what my sample size was. Magnetism would be another one. I could have a small piece of iron or a larger piece of iron, and that iron metal should be magnetic. I could have 1 gram of sulfur, or I can have 500 grams of sulfur, and I could observe that it's a yellow solid. I can observe odor, whether I have 1 little drop of ammonia or I have an entire bottle of ammonia. I take the cap off the bottle. Ammonia has a very distinct odor to it. I can tell that it's a colorless liquid with this distinctive odor. These are all properties that are observed regardless of the quantity. Sometimes people will get a little bit confused with that melting boiling point. But again, this is something you could find on an MSDS sheet. Water boils at 100 degrees. Water melts at 0 degrees Celsius. That's independent of the sample size. Now, obviously, if I have like 100 milliliters of water versus 1,000 milliliters of water, when they boil, they will both be boiling at 100 degrees. What's the difference? Are you thinking somewhere along the lines that the more water you have, just the more time it's going to take to get to 100 degrees? It's just going to take more time to reach that boiling point. So yeah, the little 100 milliliter sample, that's going to boil a lot quicker. But when it boils, it's 100. The larger sample, if I had 1,000 milliliters of water, it's just going to take more heat. It's going to take longer on the hot plate. But eventually, by the time it boils, it'll be the same boiling temperature, 100 degrees, independent of quantity. Extensive properties do depend on the quantity of your sample size. So these I would think of like volume, mass. Obviously, if I have a larger sample size, it's going to have more mass. If I have 100 milliliters versus 1,000 milliliters of water, 1,000 milliliters is a greater volume. There's more particles present. Intensive properties are independent of quantity. Doesn't matter your quantity or your sample size. You'll get the same observation. Extensive properties do depend on quantity. Now here's one, and again, that always kind of tricks people. What about density? What about density? We'll study density in the lab a little bit. It's a ratio of mass to volume. Where does does density go? Intensive or extensive? This will stump people. Because they'll look at the extensive properties and they'll be like, well, what do you know? I just listed volume and mass, and that's what makes up density. But then you start thinking about it and you say, but wait a second. Density is a ratio of mass to volume. What if I had, I don't know, 10 grams? And it had a volume of, I don't know, 5 milliliters. My density would be 2 grams per milliliter. It's a ratio, mass to volume. What if I double my sample size? What if I double my sample size and I make it 20 grams? Well, guess what happens if you double the mass? You double the volume too, right? So if I have 20 grams, it's probably going to have a volume of about 10 milliliters. And what do you know? The density is the same. Density is a ratio of mass to volume. This is another property that you can find on an MSDS sheet. Something that's consistent for a given substance, regardless of its sample size. So density belongs up on top. It's an intensive property. If you have more mass, you're going to have more volume. And the ratio ends up being the same. But this, again, it'll stump people because they see like mass and volume and they're like, oh, but those are extensive. They depend on your sample size. Individually, yes. Individually, they're extensive properties. But now in density, I'm looking at them as a ratio. This density is a property that is the same, regardless of your sample size. It's actually a question on the final exam, which isn't for a while. But it's kind of a trick question where it says like, oh gosh, I forget what it is. Like a piece of copper has a density of, I don't know, 2 grams per milliliter, or whatever it might be. And then it says something like, this piece of copper is cut into 2 pieces. What can you say about the density of the 2 pieces of copper? It should be the same. So yeah, now you have like a smaller particle, you have a smaller piece of copper, so the mass is smaller, but its volume is also smaller. Density, intensive property. You'll never ever get that wrong.